Hi there, my name is Roger Williams. This is the presentation Games People Play. This is another video in the Congruent Light series of videos. This is the first Congruent Light game. Now, I've been using Mathematica for several years. I was considered to be of immense depth and breadth. But like other applications I think are amazing, this thing just grows. It grows and grows. I've been working on a couple of videos to demonstrate the manipulate function to show how to make interactive application animations. It was while working on this that even though I've been a hardcore geek for many years, I've never really gotten into gaming. So when this turned up inside Mathematica, I was pretty shocked. And I went out to buy the device. And here I'm going to show the very first experiments. So before we start, let's see the awesome power of this thing called manipulate. And here's a quick example using geometry, lighting, and other stuff. And I move the code into a separate cell. It comes directly from the help manual for the lighting specification. And there's the URL. So it'll ask me to run the initialization scripts, and here it is. So it's a little, looks like a little, like a stage. There's three columns. There's 3 point sources which appear to emit light. The shadow is against the stage. A red, a green, and a blue. I don't really know how this works. I'm just going to pick it. And obviously when I pick this, it moves the point sources back and forth. When red and blue are together, it makes purple. So there's obviously some intelligence here. When red and green are together, it makes yellow. And manipulate also allows me to fire this off automatically as an animation. And you can go faster and slower. Let's see here. There we go. So you can see that manipulate's a very powerful beast. And I'll show you the code if we have time at the end. Okay, lights, camera. So the gaming hardware, let's take a look at the device, and we'll just use the imaging capabilities of Mathematica, which allow me to grab this image from the vendor's website and bring it into Mathematica. And there's a thumbnail, and there's what it looks like. And I didn't really know what this was a couple of weeks ago. It has 2 main rocker switches and another rocker here. And then there's 4 buttons, numbered buttons here, and there's 2 other buttons, and there's actually 4 other buttons on the other side of the thing, which you can't see in this picture. But this is the Logitech Dual Action GamePad. There are other gaming interfaces which will work, but this one is pretty cheap, and it's mentioned in the Mathematica documentation as something they tested using, so I wanted to get the same one. So that's the hardware. So let's look at a simple example. These are geometrical examples at the beginning. And all these examples, I'll use the mouse first to familiarize us with the application. Then I'll try out the gaming interface. And this first example is the superposition of 2 sine waves. So you can see there's 2 sine waves here. They're added together. The amplitude and the frequency of the first one, the amplitude and the frequency of the second one. So let's go ahead and do this. And I made the amplitude of the first one start at 0.1 rather than 0, because otherwise you wouldn't see anything. So I'll go ahead and move the frequency of the first one, and you can see how it increases the frequency of the sine wave. If we move the amplitude, it'll make the amplitude bigger, of course. The frequency of the second one doesn't appear to do anything because there's no amplitude. If I add the amplitude in, you can see how it affects the superposition, the addition of the 2. Now if I go over here and use a game interface, let's see here. I can go amplitude up or down by itself. I can go frequency left and right by itself, frequency 1. I can go amplitude 2 up or down. You can see how it's affecting the curve. And frequency 2, you can see how that affects the curve. Now I can also, because this is a gaming thing, I can do all of them at the same time. And it really allows me to explore the space and see what the different settings will do. So obviously that's pretty cool. You can see this is 6 lines of code. Now, because Mathematica is a programming system, let's look quickly at how to interface to the device. This shows all the buttons, and you can see here how it picks these up when I hit them. Let's use command completion. So here's controller. I'll use Control K, and I'll pick up controller information. And I execute that, and here's the control device Logitech. And here's the Mathematica controls. And so here are all these controls. Now watch this when I hit the gaming device with it. See how they all change? And if I hit some of these other buttons, which I haven't been using, they all change as well. You can see them all go true and false. So all of these can be checked in your Mathematica code to control the animation. So obviously there's a lot of material there. That's the device interface. Now I'm going to quickly tour some applications and show you how the GamePad works with them. And this shows the morphing of a sphere and a torus. And notice that the code is basically typeset. Phi over 2 is some kind, I don't know if that's phi actually. And this makes it easy to find bugs and match it up against formulas in a book. And I know of no other system which allows the execution of a typeset equation. So let's go ahead and try this. And I'll use the mouse first. And you can see how it kind of morphs into a donut, which is a torus. And if I connect this to the gaming interface, like this, you can see I can really go nuts here. And I can make it go through its steps. You can see how it's drawing and rotating at the same time. Kind of slows down the middle because it's doing more calculations. But obviously this is pretty cool. And this is a little bit longer, so this is obviously the parameterization of a sphere, parameterization of a torus, and in the animation. Morphing a sphere. A Lissajous curve, this is a basic Lissajous curve. Uses the presentations package. And you can see there's a Lissajous curve. It turns out it's also an addition of sine waves.